All right, it's Mr. P. Helps with Geometry. This is Unit 1, Topic 2, Part 2, Lesson number 4. So we're going to be describing a series of combinations that carry a figure onto another, starting with an order of rotational symmetry warm-up. This has an order of rotational symmetry of 2, and the reason why is because it'll be the exact same shape if you spin it 180 degrees and 360. So it'll look exactly the same twice if you turn it 360 degrees, whereas this will look the same 5 times. This will only look once exactly the same, because remember, if you turn it upside down, it's going to look like a 7, not an L, and then this has an infinite amount of ways that you can turn it. You can turn it pretty much any degree, or any tenth of a degree, any hundredth, any thousandth, and so forth. All right, so in this one, we're talking about being able to do more than one transformation, or what we call a series of transformations. If I'm going to reflect this over line M, point C would be about right here. Point B would be about right here, so that's the same height and equal distance to line M. And A would be roughly about right here. So I'm going to call all of these primes because they are the copies of the original. And then if I reflect it again over line N, A would be about right here. So I'm going to call it prime prime. C would be about right here, and B would be about right here. Now, notice that this final image looks very much like the pre-image over here. So pre-image, we got our intermediate image and our final image. If I took all of these and I slid it over along that given vector that I just did, it would be the exact same distance for all 3 of the points. So it is a translation to make it back, map it back onto the final image. Same thing goes for this one. So when you do this, it's going to end up looking like something like this, and then you flip it over to here, and it's going to be over here in this section right there. And then if you basically, if you rotate it 180 degrees around, it would look the exact same around this point of where lines M and N intersect. Now, so the other thing we're going to be doing in this video is describing a series of transformations. This is a little bit better because now you have the picture. Step 1 is reflecting it over this given line segment, which we don't know the name of. Then we are translating it in step 2 to the right along this given vector that tells you the distance and direction, or magnitude and direction, which is what we know vectors for. And then this... and there's our final limit. Oh, I'm sorry, I missed the first one. So before the flip, there was a rotate. ABC rotated around point P, and that happened to be 90 degrees. Now, the reason I know that is because what I can do is I can connect point B to point P, and then connect it to where it rotated, and you'll see that it makes a 90-degree angle. Now, I don't know if it's exactly 90 degrees, but it certainly looks like it's about 90 degrees. And I know we're not really supposed to make assumptions, but in this case, we don't really know the exact amount. All right, so in page 27, we're taking this kite-looking figure here, ABCD, and turning it into WXYZ. So we're starting here, we reflect over the given line segment, then we rotate it around point P, 90 degrees clockwise, and then we slide it along the given vector, and that would be it. All right, page 28 says, reflect this over the x-axis and then reflect over the y-axis. Well, as we might have stated in a prior video, reflecting over x and the y is basically the same as a 180-degree rotation. 1, 2, 3, 4, 1, 2, 3, 4. This is going to be 5 away, so 5 away, and then I can connect, and there's the reflection over the x-axis. And then do the same thing across the y-axis. 2, 3, 1, 2, 3. So here, and 1, 2, 3, 1, 2, 3. Now, if you look at this final image right here, you will see that this is basically the same thing as this, only it's been rotated 180 degrees around the origin. So one more says, reflect over the x equals -4. 1, 2, 3, 4. So that would be right here. So 1, 2, 3, 1, 2, 3. 1, 2, 1, 2. That next point would be 3 away. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. All right, connect these points up. So that's a reflection. And then it says translate MATH 8 spaces to the right. So I'll go 1, 2, 3, 4, 5, 6, 7, 8. Now the question becomes 1, 2, 1, 1, 2, 1. Question becomes, how could I map the pre-image onto this final image, right? Well, I notice that's 1, 2, 3, 4, 5, 6, 7 away from this line. 1, 2, 3, 4, 5, 6, 7 away from that line. So it looks like I basically could have just mapped this, reflected it over the y-axis, and that would have basically done the exact same thing, which would have moved it right here after it's moved 8 spaces to the right. And then we have a couple of rotations. And I think I'm actually going to call this video right there, because basically I've shown you exactly what we're talking about here. We're talking about doing 2 transformations, but I could then do this all in 1 transformation. So it's just a matter of looking at what your final image is and comparing it to the pre-image and thinking about rotations, reflections, and translations, all the different transformations, and seeing how else I could have gotten it there. All right, thanks again for watching. Have a great day.